Okay guys, so this is going to be converting radians and degrees and drawing angles example problems. Okay, so from Algebra 1, we've labeled the Cartesian coordinates. This is going to be Quadrant 1, Quadrant 2, Quadrant 3, Quadrant 4. If you're ever in doubt, it always makes a C. Okay. Now, some information that you don't know is that we're going to always label this, the positive x-axis, the angle 0 or 360 degrees. And if we're in radians, it's going to be 0 or 2 pi radians. Okay, 90 degrees is going to be the positive y-axis. So that's going to be 90 degrees, or we're going to say it's pi over 2 radians. The negative x-axis is going to be 180 degrees, or pi radians. And the negative y-axis is going to be 270 degrees, and it's going to be 3 pi over 2 radians. So we're always going to start off by labeling our axis like that. Now, when we go to identify quadrants a little bit later in this lesson, we're probably going to have to get a common denominator when we're dealing with the fractions, okay? Next point we need to make is that this is always going counterclockwise is positive. If I start going clockwise, it's going to be negative angles. So I think we're going to deal with that a little bit later in the lesson, so just be prepared for that. Now, some other information that you're going to need, okay? This quadrant 1 answer is always going to be alpha. Quadrant 2 is going to be 180 minus alpha, or it's going to be pi minus alpha, and I'll teach you what that means in a little bit. This is going to be 180 plus alpha, and this is going to be pi plus alpha if we're in radians, and this is going to be 360 minus alpha, and this is going to be 2 pi minus alpha for quadrant 4. Okay, so just keep that in mind as we go through. We're going to be using that this whole unit with trig stuff. And one last thing, a little memo you need to make sure you know. Quadrant 1, we're going to remember that as A, all. Okay. Quadrant 2 is going to be students. Quadrant 3 is going to be tangent, which is going to stand for take. And quadrant 4 is going to be calculus. So all students take calculus. Okay. Another way you can remember it is all strippers take cash. That's going to be the PG-13 version of that. Most people remember it that way. Okay. So we might not be using that this lesson, but we're going to be using that throughout this unit. Okay. So what you need to know is that in one full circle, there's 360 degrees. Okay. And 360 degrees is equal to 2 pi radians. Okay. So what we're going to be using is that conversion factor to go between degrees and radians in the first portion of this lesson. Okay, so our first example problem, we're going to take 315 degrees and we're going to convert it to radians. So I'm going to say 315 degrees, I'm going to put it over 1. There's 360 degrees to 2 pi radians. Okay, now I'm going to use my calculator. 315 times 2, I'm not going to multiply by the pi, I'm just going to leave the pi alone, divided by 360, and I should get 7 pi over 4. So we're going to convert it to a fraction. Most of these come out to be nice fractions. Okay, so 7 pi over 4 radians. Negative 45 degrees. Okay, so negative 45 degrees, I put that over 1. There's 360 degrees and 2 pi radians. Okay, you always want to make sure your units cancel diagonally, just like you do in dimensional analysis with chemistry and physics. And divided by 360, and we should get a negative pi over 4. Okay, 135 degrees. So we take 135 degrees and put it over 1. There's 360 degrees to 2 pi radians. Okay, so we're going to leave the pi alone, so 135 times 2, and we're going to divide it by 360, and we get 3/4. Okay, if you need to hit math, enter, be my guest for that. Negative 90 degrees. Okay, so negative 90 degrees over 1. And we're going to take 360 degrees. And we're going to put 2 pi radians on top. Okay, so I should get negative 90 times 2 divided by 360. So it should be negative pi over 2. Okay? Convert that to a fraction if you need to. Okay, so we hit math, enter to convert it to a fraction if you didn't know already how to do that. Okay, 150 degrees over 1. 360 degrees to 2 pi radians. Okay, so I'm going to do 150 times 2 divided by 360, and I should get 5 pi over 6. Okay, and the last one, 105 degrees. So we'll do 105 degrees over 1. There's 360 degrees to 2 pi radians. Okay, so I'm going to do 105 times 2 and divided by 360. And I get 7 pi over 12 radians. Okay. Now, we're going to do the same thing, use the same conversion factors, but we're going to be going from radians to degrees. So I'm going to have to flip my conversion factor. Okay? So, negative pi over 2 radians. Now, we said that there's 2 pi radians to 360 degrees. Now, we can see that there is a pi on top and a pi on bottom, so we're going to cancel that, so the pi's cancel. So I'm just going to do a negative 1/2, okay, times 360, and I'm going to divide it by 2. Okay, so I should get a negative 90 degrees. Okay, pi over 6 radians, I'm going to do pi over 6. Okay, there's 2 pi radians to 360 degrees. The pi's will cancel. So 1/6 times 360 and divided by 2, and you should get 30 degrees. Okay, negative 5 pi over 6. And there's 2 pi radians to 360 degrees. We're going to make sure our units cancel diagonally. Pi's will end up canceling. So we get negative 5/6 times 360 and divided by 2. It should be a negative 150 degrees. Okay, now 11 pi over 12. 11 pi over 12 radians over 1. 2 pi radians goes on bottom. 360 degrees goes on top. Okay, your pi's will end up canceling. Looks like that. Now, this is important, not only for trig, but this does show up on your SAT, so you need to make sure you know how to do degree and radian measurements. Okay, so you should get 165 degrees. 13 pi over 18 radians. Sorry, I keep hitting my camera. Okay, so we've got 2 pi radians to 360 degrees. Okay, so we do 13 over 18 times 360 divided by 2. Okay, is 130 degrees. And then 2 radians. Now, what's different about this question is there's no pi. Okay, so we know that there's 2 pi radians to 360 degrees. Okay, so when we put this in the calculator, we do 2 times 360. Okay, now since we're divided by 2 pi on the bottom, it has to be in parentheses. Okay, So I get 114.592 degrees. Now, we're always going to go 3 decimal places in calculus, so you need to make sure that you are familiar with that. And you also need to make sure you show your setups just like I did. So if I do it one way, that's exactly how you need to do it. Okay, so I'm going to sketch the following angles in degrees or radians, okay? So we have some examples that are in degrees and some of them are in radians. So the first few are in degrees. Okay, so when I sketch an angle, this is often the hardest part of this lesson, and if you can sketch an angle, then you're doing pretty good. Okay, so I'm always going to label 0, 90 degrees, 180 degrees, and 270 degrees when I'm sketching curves. Now, 150 degrees lies in between 90 and 180, right? So when I sketch this, this is going to land me in quadrant 2, okay? And that's all you have to do. Now, make sure that in the next lesson, we're going to be finding something called the reference angle. So the reference angle is the distance, the angular distance away from the nearest x-axis. So we would say in this case, your reference angle would be 30 degrees because 180 minus 150 is 30 degrees, okay? So we're not going to do that right now. We'll do that next lesson, but that way you know how to do it. Okay, the next angle we're going to sketch is negative 60 degrees. Okay, now negative means we're going to be going clockwise. Okay, so we have to label it negative 90, negative 180, negative 270, and 0, and negative 360. Okay, so negative 60 is in between 0 and negative 90 degrees. Okay, so it's going to be a quadrant 4 answer. We're just going to draw it like that. It doesn't have to be perfect. Okay, so it's going to be 60 degrees away from the nearest x-axis, so your reference angle would be 60. A reference angle is always positive. Keep that in mind. Next one, 300 degrees. Okay, so we'll go 0, 90, 180, and 270. So, and then this will be 360 if we go full circle. Now, we're looking for 300 degrees. So 300 degrees lands in between 270 and 360. So our angle looks something like that. And we're 60 degrees away from the nearest x-axis, so my reference angle would end up being 60. 480 degrees, okay? So we know that one full circle is going to give me 360 degrees. So it's going to be more than one full circle. So let's go ahead and label 0, 90, 180, 270, and this is going to be 360. Okay, so 480 minus 360, if you don't know how to do this mentally, is going to be 120 degrees. Okay, so it's going to be one full circle, and then I have to go another 120 degrees. Like that. Okay, so we know that 120 is in between 90 and 180. And your reference angle for this case is going to be 60 degrees because 180 minus 120 is going to be 60 degrees. Okay, this is going to be called a coterminal angle whenever you have multiple circles involved. Okay, now let's do our radians examples. Okay, so 5 pi over 4. Okay, so this is 0, and this is 2 pi. This is pi over 2. This is pi. And this is going to be 3 pi over 2. Now, when we're dealing with radians, especially the fractions, we're pretty much going to be dealing with these 2 points right here. Now, I'm in fourths, okay? So what I'm going to do is I'm going to multiply the left-hand point and the right-hand point by 4 over 4. Whatever the common denominator is going to be. Okay, using a little bit of common sense, pi over 4 would land you quadrant 1. 3 pi over 4 would land you quadrant 2. 5 pi over 4 would land you quadrant 3. And 7 pi over 4 is going to be short of 8 pi over 4. If you want to go through and get this in fourths, this doesn't always work out very nicely, but on this one it does. This is 6 pi over 4. So 5 pi over 4 is going to land you in quadrant 3. Okay, so... Now, most of the time when we're dealing with reference angles with radians and pies, it's just going to be the fraction. So you're going to leave the pi and you're going to use the denominator. So it's going to be pi over 4. Okay, next one's negative 11 pi over 6. Okay, so I'm going in the negative direction, so I need to label my points going clockwise. Okay, so I'm dealing with fractions, so I'm in sixes, so I'm going to multiply this point by 6 over 6, and this one by 6 over 6. Okay, now a negative 11 pi over 6 is almost to negative 12 pi over 6. Okay, it's past negative 6 pi over 6. Okay, so when I go to label this and draw it out, it's going to look something like that, because it hasn't made it quite to negative 12 pi over 6. 16 pi over 3. Okay, so 0, pi over 2, pi, and 3 pi over 2. Now I am in thirds, so I have to multiply my left point and my right point. That's 2 pi, sorry. Okay, now 1 full circle is going to be 6 pi over 3 radians. Okay, so 1 full circle gives me 6 pi. 2 full circles would give me 12 pi. And then I would have 4 pi over 3 left over. Now, 4 pi over 3 is going to be in quadrant 3 down here, because it's past 3 pi over 3. Okay. Now, the last section of your notes, we're going to identify which quadrant each angle lies in. Okay. So let's draw it. That's the easiest way to do this stuff. So we're in twelfths. So this is the point 0, pi over 2, pi, and 3 pi over 2. Now we're in twelfths, so this is going to be 12 pi over 12, and this is going to be 2 pi, and we're going to multiply it by 12 over 12, so it's 24 pi over 12. Okay, so pi over 2, if I'm in twelfths, I would multiply this by 6, and I would multiply this by 6. So this would be 6 pi over 12, because 6 over 12 is 1/2. So 5 pi over 12 is going to be somewhere over here. So it's going to be quadrant 1. Okay, negative pi over 3. Okay, so if I'm going in the negative direction, 0, this is negative pi over 2, this is negative pi, and this is negative 3 pi over 2. So negative pi over 3 is less than a half, so a third is less than a half. We all know that from 4th grade math. So that means that I'm going to end up in quadrant 4. Okay? Make sure the negative direction means we're going to be going clockwise. Okay, 23 pi over 12. We're dealing with twelfths just like we did earlier in the example problem, the first one. Okay, so this is 0. This is going to be pi over 2. This is going to be pi. And this is going to be 3 pi over 2. So since I'm in 12ths, I'm going to multiply the left point and the right point by 12 over 12. Okay, now I see that 23 is just shy of 24. So that means we're going to land in quadrant 4. And the last one. Negative 5 pi over 4. So if we're going to go the negative direction, we're going to label our axis like that. Okay, so we're in fourths because of this right here. So this is going to be 4 pi over 4, negative 4 pi over 4. This is going to be negative 8 pi over 4. Okay, so if I'm in quadrant 4, it's going to be a negative pi over 4 because 0 is right here. Negative 3 pi over 4 would land us over here. And negative 5 pi over 4 is right past negative 4 pi over 4. So it's going to look something like that. And it's going to land you in quadrant 2. Okay, so this has been converting in between radians and degrees and drawing angles in degrees and radians. So hopefully you found this video useful. You will complete the converting radians and degrees and drawing angles practice problems after this. So make sure you show your work and setups just like I did. Thanks, and have a good one.